This video in the Pure Maths 1 series is on geometric series, and it deals with geometric sequences. Now, in a previous video we looked at arithmetic sequences, and we saw that an arithmetic sequence is one in which, in order to get the next number in the sequence, we add the same number. So in this case we start with 2, we add 3 to get 5. The next term 8, we add 3 to 5, we add 3 to 8 to get 11, we add 3 to 11 to get 14. In a geometric sequence, however, we multiply each term by the same number to get the next term. So in this case we multiply 2 by 3 to get 6, we multiply 6 by 3 to get 18, we multiply 18 by 3 to get 54, and multiply 54 by 3 to get 162. So we can say in this sequence, the first term u1, to use our usual notation, u1 is 2, u2 is 2 times 3, which is 6, u3 is 2 times 3 times 3 again, or 2 times 3 squared. u4 is 2 times 3 squared times 3 again, which is 2 times 2 cubed. That's 54. And u5, the fifth term, is 2 times 2 cubed, 2 times 54, times 3 again, to give us 162. So looking at the pattern, we see that the first term 2 is in each term, and then we multiply by the common ratio, the number 3, to the power of, well, for the first term we can say that is 2 times 1, or 3 to the 0. For the second term we've got 2 times 3, we could call that 3 to the power of 1, and subsequently we have the third term 2 times 3 squared, the fourth term 2 times 3 cubed, the fifth term 2 times 3 to the 4. We see the number in the index here, 4, is of course 1 less than 5, 3 is 1 less than 4, 2 is 1 less than 3, and 1 is 1 less than 2, and 0 is 1 less than 1. So we can write a formula for this. un, the nth term, is 2 times 3, and then it's 1 less than n, or n minus 1. The number 3 is known as the common ratio. If I take any two terms, let's say u4, and then divide it by the previous one, u3, we'd get 2 times 3 cubed over 2 times 3 squared, and the 2's cancel, and 2 3's on the bottom will cancel with 2 on the top to leave us 3. You can see that this will work with any two terms, 5 and 4, any two consecutive terms of course, 5 and 4. The fifth one, 2 times 3 to the 4 divided by 2 times 3 cubed, will just also give us 3. 3 is the common ratio. It's the same number when you divide one term by the previous term. So 3 is the common ratio. In general, for a common sequence with first term a and common ratio r, the nth term un is the first term a times a common ratio r to the n minus 1. In the example we had the first term 2 and the common ratio 3. So this is a formula which you will need to know. Here's an example. Example 1. Find the 10th and 20th terms of this geometric sequence 3, 6, 12, 24 and so on. Well, we have our formula un equals ar to the n minus 1. First of all, we want the 10th term, that's u10, which of course will be ar to the 10 minus 1, or 9. So ar to the 9. So we need to know a and r. Well, a is the first term, a is 3, and the common ratio r, well, you take any two terms and divide one by the previous. So we could say 12 divided by 6 is 2, or 24 divided by 12 is 2, 6 divided by 3 is 2. So u10 is a, which is 3, times r, which is 2 to the power of 9. That's 3 times 512. The 20th term, u20, would be 3 times 2 to the power of 20 minus 1, or 2 to the power of 19, which I think I'll leave in index form. I mean, that would be a very large number. Second example, find the first term of 13927 and so on to exceed 10,000. So in this geometric sequence, we have the first term is a, first term a is 1, and the common ratio, well, we're multiplying each term by 3, so the common ratio r is 3. So our general term un is a, or 1, times r, or 3, to the n minus 1. So un is 3 to the n minus 1. Now we want this. We want to know which term first exceeds 10,000. So we want to know what is the value of n for which un is greater than 10,000, or 3 to the n minus 1 is greater than 10,000. Now this inequality, we have the unknown n in the power, the index of 3 here, and when we have powers, unknowns in powers, the best technique, or the technique to use, is taking logarithms. The logarithm, the graph, I think we if you've seen in a previous video, looks like this. Which is an increasing graph, an increasing function. If we have a value of x, and we increase the value of x, we also increase the value of y. So this is our first value of x, this is our second value of x, this is the first value of y, this is the second value of y. y2 is bigger than y1 if x2 is bigger than x1, and that's always true wherever we have x1 and x2, because the graph is increasing. It always goes up as we increase x, which means if we take the logarithm of, we can say that the logarithm of 3 to the power of n minus 1 is greater than the logarithm of 10,000. If 3 to the n minus 1 is greater than 10,000, then, so if that is at x2, 3 to the n minus 1 is x2, and 10,000 is x1, we can say the logarithm of 3 to the minus 1 is, which would be y1, y2, beg pardon, would be greater than the logarithm of 10,000, which is y1. Therefore, we can take logarithms of both sides, and the inequality is still true. So the logarithm of 3 to the n minus 1 is greater than logarithm of 10,000. The best base to use here, well, if it's 10,000, would be base 10, but it's true for any base. If in this case, use base 10, the logarithm of 10,000 is in fact 4. So the logarithm of 3 to the n minus 1 is greater than 4. You will know from previous videos on logarithms that the logarithm of a number to a power, by one of the rules of logarithms, we can move the power to multiply the logarithm. So we have n minus 1 times log 3 is greater than 4, or n minus 1 is greater than 4 divided by log 3. So I'm dividing both sides by log of a logarithm, which you can divide an inequality by a number, providing the number, of course, is positive. Log 3 is a positive number. If you look up log 3 on the calculator, log 3 to base 10 is it's about 0.477. Now I would be careful here. Sometimes, for example, if you had the log of a number less than 1, say log of a half, 0.5, if you look that up, you find it's minus 0.3, about 0.301. Well, that's a negative number. Now it doesn't look like a negative number when you see it in logarithmic form, log of a half, log of 0.5, but it is negative. The logarithm of any number less than 1, we can see on the graph here, this is 1 there, so any number less than 1, the logarithm is negative. So you would have to reverse the direction of the inequality symbol if you divide by a logarithm of a number less than 1. So n minus 1 is greater than 4 over log 3, n therefore is greater than 4 over log 3 minus 1, and if we use the calculator, we find that n is greater than approximately 9.384. So because n is a whole number, n is equal to 10, the first number greater than, or n must be greater than 9.3 for so the first one that to exceed 10,000 is when n equals 10. So if n equals 10, u10 is 3 to the power of 10 minus 1, 3 to the power of 9, which is 19,683. For our third example, we have an algebraic example. The first three terms of a geometric sequence are x1, x plus 1, x plus 2, and x plus 5. Find x, and then we can find the terms of the sequence. Well, of course, if it's a geometric sequence, they have a common ratio. Therefore, x plus 2 divided by x plus 1 must equal x plus 5 divided by x plus 2. So we have an equation to solve. If we can cross multiply, x plus 2 squared equals x plus 1 times x plus 5, and then we can expand both sides. X squared plus 4x plus 4 is equal to x squared plus 6x plus 5. Simplifying, we get 2x equals minus 1, or x equals minus a half. So the sequence is x x minus 1, so plus 1, so minus a half plus 1 is a half. X plus 2, which is minus a half plus 2, which is 3 over 2, and x plus 5, which is 9 over 2. Okay, that's the end of this video. Now return to Study Smart and you'll find another video where we'll show you how to find the sum of a geometric series.